Cloud is all about choice. Take full advantage of multi-cloud with Couchbase, a geo-distributed, cloud-native data platform built to power your business-critical applications. Avoid cloud lock-in and open up a world of possibility. Start a revolution with Couchbase. Learn more at couchbase.com/cloud.
Hello and welcome to the InfoQ podcast. My name is Wes Reisz and I chair a set of software conferences called QCon. As part of my role with QCon, I get the opportunity to speak with each of our speakers. Those interviews discuss QCon's audience and how we try to shape and position the conference. In addition, I record interviews with each of our speakers. These podcasts are glimpses into some of those conversations, albeit a bit deeper. The next QCon is this June in New York. If you like what you hear here, I hope you'll be able to join us for 3 more days in New York. On today's podcast, we're talking to Colin Eberhardt. Colin is a technology director at Scott Logic in the UK. Scott Logic recently published a white paper entitled The Web Assembles, where Colin and his co-author Chris Price discuss what WebAssembly or WASM is and what they feel the future holds for this technology. Colin recently spoke at QCon London about the topic, and on today's podcast, we discuss what WebAssembly is, a bit about the history of JavaScript, or scripting in the browser, and how we got to where we are today, information about WebAssembly, WebAssembly 2.0, including the threading model, the GC, some of the handicaps and some of the possibilities with WebAssembly, and then we wrap up with some of the bold predictions that Colin made in this paper. As always, thank you so much for joining us on the InfoQ podcast. Colin, thank you for joining us on the InfoQ podcast.
Cool, no problem.
So let's start off with a definition. WebAssembly, or WASM, you may hear it called a WASM. It's a web standard that defines a binary format and a corresponding assembly-like text format for executable code in web pages. That WebAssembly-like text format trips me up. So what does that mean, and is that a good definition?
Well, it's a deeply technical definition. I think it's the kind of definition that you read, but it doesn't really tell you much about what it actually is. So in slightly simpler, slightly less technical terms, interactive applications within the browser depend on the JavaScript virtual machine, which runs the JavaScript language, and that's the way it's been for the past 20 or so years. WebAssembly brings another kind of virtual machine to the browser, another kind of runtime. But the difference here is JavaScript is a very high-level language, originally designed as an interpreted language, whereas WebAssembly is a much more low-level language, which is where the assembly part of the name comes from. So it's a new low-level language that runs within the browser.
What does that assembly-like text format mean?
If you're doing assembly language programming for a microprocessor, for example, the instruction set that the processor understands is a low-level machine code. It's bytes and so on. So most assembly languages will have a slightly more readable version, which is the assembly language. So you'll have opcodes rather than being bytes, there'll be short mnemonics. So the text format that you see for WebAssembly is just a more human-readable version of the binary format, which is the underlying WebAssembly itself. So it's a very, very light bit of syntactic sugar. There's almost a one-to-one mapping between the text format and the binary format.
So when we talk about a binary format that runs within a browser, this sounds like an RIA. It sounds like Flash. It sounds like Silverlight. At least that's where I go. How is what we're talking about now with WebAssembly different than writing Flash?
Yeah. Part of the reason why people think it sounds similar is because one of the motivations, one of the goals of WebAssembly is to create a new assembly language, which is a compilation target for a wide range of other higher level languages. So through WebAssembly, we're now seeing C#, Java, Rust, C++. We're seeing a whole host of other languages now running within the browser. So that immediately makes people think of how they used to be able to run those kind of languages in the browser. But there are some very fundamental differences in the way that this is being achieved. Flash, Flex, Silverlight, and so on used the plugin model. And the plugin model, to put it very, very simply, is it's a bolt-on to the side of the browser that lets you have a completely different execution environment and then a very, very restrictive API for communicating between that runtime and the first-class runtime within the browser. WebAssembly isn't like that. It isn't this bolt-on at the side. WebAssembly is very tightly integrated within the JavaScript virtual machine. There's a very close synergy between the two. So that's one sort of technical difference. The other difference is more about the way in which it was created. So Silverlight was a Microsoft invention pushed by Microsoft. Flash was an Adobe creation. They were created in an era of competition. So there was always competition between the different plugin vendors, and then there was competition and friction between those and Apple, for example. WebAssembly has been created through collaboration. So WebAssembly has been created with significant representation from Microsoft, from Apple, from Google, for example. So it's been created in a very different way as well, which has a significant impact on its adoption, which is why it's been adopted and moved into production in a very short space of time.
There's a couple things that I want to key off of what you just said. One is collaboration, but the other thing that I want to do before I get there is understand the core problem that WebAssembly was trying to solve. What is the core problem? Is it performance? Is it security? Is it integration? What's the core design challenge that WebAssembly was solving?
Personally, when I look at the way we run applications in the web at the moment, I look at them and I think that is incredibly inefficient and convoluted. We write our code using JavaScript, and typically people use things like Babel, they use TypeScript to create a quite a modern feeling language around JavaScript, which is all great. We have complicated and advanced build tools that do things like tree shaking, minification, transpiling, and so on. So we've got quite a mature development ecosystem and compilation framework there. But to pass that code to the browser, its only option is to transpile it down to one of the more basic JavaScript versions and send it in text format over the web, which is pretty inefficient. The browser then has to parse that. It has to parse it into an abstract syntax tree. Then it will initially run it in an interpreter, then move it through various different optimization levels so that your code gets faster and faster again. So we've got, on the development side, we've got some quite advanced intelligent tooling. Within the browser runtime, we've got an advanced runtime with multiple levels of optimization. But in the middle, we've got this really horrible mechanism whereby we're still delivering it in a very basic and inefficient text format, because that's the way that the web was designed. We've got this nasty little bottleneck there. And the impact of that bottleneck is twofold. One is the time it takes to actually deliver your code into the browser and get it up and running. That's worse than it should be. The other is the overall performance and the time it takes to warm up your code and actually get your JavaScript code running quickly within the browser. So ignoring the fact that WebAssembly brings different languages to the web, the way JavaScript itself is executed in the web is pretty inefficient. And WebAssembly, in simple terms, solves that.
Interesting. So one of the things you just said is that solving the problem that it takes to deliver the JavaScript to the browser. When we're talking about this binary, aren't we talking about now something that is going to bloat the web? It's going to make things bigger. We're talking about being able to write binary code and being able to deliver it to the browser. That seems rife for abuse, that we're just going to be just sending these huge buckets down towards the browser.
Yeah, so I can understand that concern. And I think it's worth considering that within the web, we've always optimized for performance. We've always optimized for size. Whereas on the desktop, there hasn't been that much pressure and that much forcing us to perform that kind of optimizations. If a desktop executable's 50 megabytes or 100 megabytes, generally it doesn't matter. But if you add an extra 20% to the payload of a website, people worry about that. People care about that. So that particular concern hasn't gone away. And technically speaking, if you take a simple algorithm, let's say, for example, an algorithm that renders a Mandelbrot fractal, that's a relatively simple piece of code. If you compile that to minified JavaScript and compile that to WebAssembly, the WebAssembly equivalent is going to be smaller because it's a binary format. So WebAssembly is always going to be a smaller format than JavaScript.
All right. Now, let's be honest. That's a very true statement. But the reality, if we think about as our computers got bigger and faster, we just wrote more and more lines of code. So just because it's smaller doesn't mean the delivery artifact is going to be smaller. It just means we're going to put more in the bucket that we're sending.
Yeah, in the web, you've got competing forces. We do have the notion of bloat. And it doesn't matter whether we're talking JavaScript, whether we're talking CSS. You'll find people, for example, putting jQuery in the page when they just use a single line of jQuery code. You'll find people putting all of Bootstrap into their website when they're only using one or two classes. However, with all these technologies, if you use them correctly, you'll find that there are ways to optimize. So for things like Bootstrap, you can construct your own build. For JavaScript, you can use things like tree shaking, which is a way to ensure that you only deliver the code you need to the browser. So yeah, you can create bloat, but again, a lot of people care about this. And as I mentioned, our tooling is quite advanced these days, and you can do some very, very clever things to optimize the delivery of your code.
Okay, let's shift just a bit. I want to kind of do a proverbial hello world example, talk about what it looks like, and then kind of start diving in a little bit deeper and talk about kind of concurrent execution and some of the memory model and some of the things that maybe how WASM is going to support kind of some features that we maybe haven't had in JavaScript, at least relatively recent. So let's start off, if just a hello world, if I'm looking at kind of an HTML document and I've got my HTML, my head, my body, how does WASM interject itself? How do you deliver WASM into that environment?
Sure. Can we for the moment pretend that hello world is not a traditional hello world and that our WebAssembly hello world just returns the sum of two numbers? Because there are various reasons why that's simpler. So if you're creating a WebAssembly module, so WebAssembly is distributed as modules, and you can have multiple modules. So if you're creating a WebAssembly module that just adds a couple of numbers together, typically you'll start with a high-level language. You won't write it in the WebAssembly language itself. So you might choose Rust or C++. Either way, you'll write a simple little function that takes A and adds it to B and returns a result. And then you'll take whatever tool chain that particular language uses to compile it into a WASM binary. The WASM binary itself has got data sections. Well, it's got sections within it that export and import functions. So it's quite similar to JavaScript modules, which themselves export and import functions. So at runtime, what happens is within your JavaScript code is you load up that WebAssembly module, it's compiled, it's validated, then it's instantiated, and then at runtime, if you called your function add, you'll see this object that has an add function, and you'll be able to invoke it. But under the hood, rather than being JavaScript code, that function will be executed within the WebAssembly virtual machine. So that's how it works at runtime. Currently, you have to load WebAssembly modules through JavaScript so that you can then compile, instantiate them, and gain access to their interface. The reason that I said, let's go for a simple function that adds two numbers together is I'm trying to hide something about WebAssembly. So one of the things I'm trying to hide at the moment is there's actually quite a lot of complexity involved in interfacing between WebAssembly and JavaScript.
That was my next question.
Yeah, calling functions is really, really easy. You can send stuff backwards and forwards, but it's the nature of this stuff, the types that you're sending backwards and forwards, which is the challenge.
You just described kind of what WASM does today, and the future is going to be very different. But I want to talk about today, or the reality, before we go into the future.
Sure.
So the example that you just gave was specifically not a hello world. It was adding two numbers together. What you described sounds a lot like, back in my Visual Basic days, we created a DLL that we would have code and we would call it into the DLL. So the way that WASM is used today, there is a JavaScript component that is then called into kind of this library component. Is that accurate?
Your JavaScript will invoke functions that are exported by your WebAssembly module instance.
So there's a little bit of stickiness or trickiness there that has to be resolved in order for you to use this today. Can you talk a bit about that?
Yeah. So probably the most tricky thing relates to the WebAssembly type system. So WebAssembly itself only has 4 types, and they're all numeric. It has 2 integer types and 2 floating point types. So what that means is implementing a WebAssembly function that adds 2 numbers together is quite trivial. But your original question was, what does a hello world application look like? Now, hello world involves strings, and WebAssembly doesn't have strings. So the way that works at the moment is one other thing that you've got with WebAssembly is a thing called linear memory. Basically, it has memory that you can read to and write to from both WebAssembly and JavaScript. So the interesting thing there is to model strings, you basically share the same piece of memory, and you basically have the same kind of rules, null termination and pointers and so on, although pointers in this case aren't quite the same as C pointers. They're just integers, indexes into the linear memory. So a real hello world application would actually look a little bit complicated and slightly strange, which is again why most people use it through a higher level language where the people that have written the compiler toolchain will have solved some of the problems like that for you.
So with the problems that you just described, does that mean WASM isn't ready for any production use at the moment? It's just still very much a prototype tool?
No, not at all. Part of the reason why it's called WebAssembly and it's assembly-like is because it's very, very low level. And if you look at, I've not done it for a while, but I used to program on PICs and microcontrollers and 6502 processors. And they have a similar concept. None of them understand strings. They have simple numeric types. It doesn't mean they're not ready for use, and it doesn't mean you can't write applications that have strings and all kinds of other types associated with them. It just means that most people won't write to the metal. They won't write the assembly language. Most people will rely on a compiler where someone else has done all that magic for them. And it's exactly the same with WebAssembly.
What are some of the success stories right now of WASM that are people that are using it in production?
Not too many at the moment because it's quite a new technology. I think some of the most interesting success stories I've seen are coming from Mozilla because they're a big backer. And some of the success stories are the ones where some of the complexities around the interface between JavaScript and WebAssembly are minimized because they're doing quite small self-contained things. So you won't find, for example, people using WebAssembly to work within React. You won't find them doing sort of DOM manipulating applications. But a really interesting one that Mozilla published is part of our common tool chain is a thing called source maps. So source maps is a technology that allows you to map minified or transpiled code back to the original source. It's actually very, very widely used and very, very important for a lot of people. And that's entirely written in JavaScript. What they've done is they've taken that JavaScript code, which is quite algorithmic, and they've ported it over to WebAssembly, and it now runs approximately 3 times faster. And from reading the blog post, it sounds like they're quite ready to be able to release that to production and ship that to developers. So at the moment, it's being used for fairly specialized algorithmic tasks. But WebAssembly itself is at the MVP phase. It's a very, very young technology, and the feature set is deliberately minimal. As the feature set expands, as the tool chain and the ecosystem around it expands, I think we'll start seeing it used for all kinds of things.
What you talked about is WASM today, but when are we expecting to see maybe 2.0, and what can we realistically expect from 2.0?
Yeah, that's a good question. At the moment, they've got quite a few things on their roadmap. We've got big, exciting sounding things like threading support. We've got garbage collection support, which will make it easier to target WebAssembly from Java and C#. We've also got some more low-level things like multi-value returns so that WebAssembly functions can return multiple values. We've also got things like host bindings, which is a way to make it easier to expose JavaScript objects to WebAssembly. We've got things like how to integrate with ES modules, so how to make a module system that works just as well for WebAssembly as it does for JavaScript. In terms of when these things will appear, I honestly don't know. I'm seeing a lot of activity in a lot of these proposals. There was a presentation by someone on the team that actually did give an indication of when some of these things will arrive. But they are much like the way that JavaScript evolves and iterates. They're not going for big bang releases. I have a feeling that when something's ready, they will ship it.
So a couple of things that you mentioned that are up and coming are the threading and the GC support. Let's start a bit with GC. Today, languages that I commonly hear with WASM are languages like Rust or C++. What languages today are targeted by WASM?
Almost every language you can think of can target WebAssembly at the moment. We've just got different levels of maturity. So C++ is highly mature because C++ was used through the development of WebAssembly and through ASM.js. Rust is gaining maturity quite quickly because the nature of Rust makes it an easy target for WebAssembly. So Rust's memory management model, the concept of ownership, is quite compatible with WebAssembly. Things like Java and C#, JavaScript as well, they need a garbage collector, and WebAssembly itself doesn't have a garbage collector. So a common approach there is to take a garbage collector and compile it to WebAssembly. So you can find C++ garbage collector implementations, and you compile that and you ship that as part of your application. But clearly that's going to add extra size, extra bloat to your module. It's also pretty inefficient. So at some point in the future, I'm sure WebAssembly will support garbage collection. I have a feeling rather than having its own garbage collector, it will just be a way of interfacing with the host garbage collector, so the JavaScript garbage collector, because that would make sense. You don't want two of them.
Yeah, that's actually what I was going to ask. How is WebAssembly going to be able to try to optimize for all these different languages with one garbage collector to kind of rule them all?
Yeah, I think it will be integrated with the JavaScript one.
What about threading? What's the threading model? Are we talking about parallel threading with inside WASM? What is the threading model going to look like?
Yeah, at the moment, the threading model is exactly the same as JavaScript. So it's a single thread of execution. And when you invoke a WebAssembly function, your JavaScript virtual machine yields to WebAssembly. So if you execute, you can't have WebAssembly and JavaScript executing in parallel. But you can execute WebAssembly in web workers, just like you can with JavaScript. So you can get parallelization. What happens with WebAssembly threading? I don't know. I'm not sure how evolved that specification is. I don't know whether they're going to hit into problems, the same sort of problems they have with things like shared array buffer, which was pulled because of the Spectre and Meltdown issues. So honestly, I don't know yet what it's going to look like, but I know it's a priority.
As I mentioned kind of before, we started off with JavaScript as this form validation tool that we used. It has evolved into something way, way different than that. Can you talk a bit about, I guess, the evolution that got us here to WASM, the kind of the steps that we went through? Where did JavaScript come from? Why was it created by Sun and Netscape to be able to have a purpose on the web? And then how did we get to today?
Prior to JavaScript, the web was a very static place. So if you wanted to create interactivity on a website, that required a round trip to the server. I clearly remember mapping applications back then where you'd click to pan the map and you'd have the whole page refresh because that was the only way to realistically have interactivity. So JavaScript was designed around that time as a way to have what I think was a modest amount of interactivity client-side. I don't imagine for a minute Brendan, when he conceived JavaScript, expected it to be as fundamental as it has become. I think at the time it was just going to be used for simple form validation and so on, where having a round trip to the server and refreshing the whole page just didn't make sense. And for that reason, JavaScript was developed in a short space of time, and it's everyone knows it's a bit of a quirky language. And unfortunately, a number of the quirks of the language are ones that we cannot change. You can't change history because people don't like breaking the web. So browser manufacturers spend a lot of time back testing to make sure that any change they make is compatible with the ever-growing range of websites. So that's where JavaScript came from. I'll give a very brief history. I mean, it battled with a few plugins along the way. And as we all know, RIA plugins, they all died for various reasons. But nowadays, JavaScript of itself is very, very mature. It's evolving at a rapid pace. People are making use of very clever techniques like transpilers. So when new language features come along, we can use them immediately because we can use a transpiler to transpile our code into an older version of JavaScript. So for various reasons, JavaScript has become a runaway success, and not just within the browser. It's being used extensively on mobile. You can program smartwatch applications. You can create node applications. You can run JavaScript practically anywhere.
What about ASM.js? What role does it play in the evolution from JavaScript to WebAssembly?
And the concerns I mentioned about just how inefficient the delivery of JavaScript is, a team at Mozilla started looking at a different approach. Plugins have been around for a while, and there have been a number of efforts to bring other languages to the web. Many have failed. So with ASM.js, they came up with this sort of proof of concept of they effectively created a low-level virtual machine out of JavaScript. They took the JavaScript language and defined a very, very strict subset of that language. And just like WebAssembly, they have the concept of memory just being an array, and they defined their own language built on top of JavaScript. And what they did with their own browser is they built into their browser technology something that understood this language that they'd created and optimized for it. I mean, the whole thing was just a very clever and, to be honest, slightly crazy experiment, but it worked.
And so how is ASM.js the bridge into WASM?
Yeah, so with ASM.js, it itself is quite similar to WASM. It defines an assembly-like set of instructions. So it's a highly restrictive version of the JavaScript language, but it's encoded in JavaScript. So it's encoded in this quite verbose and hard to understand syntax. and it's only optimized for, I believe, within the Firefox browser. In hindsight, it does feel like a very, very early proof of concept for WebAssembly.
In the introduction, I mentioned a white paper you co-authored called the Web Assembles. Where is this all heading? Where do you see WASM's future?
I think WebAssembly is going to be very important for a lot of people for many, many different reasons. There's significant excitement within the Rust community at the moment because Rust itself is a very, very popular programming language. It often comes out top of the various programming language indices published by Stack Overflow for being just very, very popular. Yet it doesn't have a significant amount of adoption. The tooling for compiling Rust to WebAssembly is very good. It's probably some of the best. So a lot of Rust developers are excited about writing Rust applications for the web, but also about whether WebAssembly will actually increase the popularity of Rust as a language itself. And I think it could well do that. I think WebAssembly could be a wave that Rust rides on, basically. You've also got the same from C#. There's the Blazor project, which was started, I believe, by Steve Sanderson and has now been adopted officially by Microsoft. So Blazor is a framework that has a C# to WebAssembly compiler and also a UI framework incorporated as part of it. So again, you've got a lot of kind of die-hard C# developers that are very excited about the opportunity of using it on the web. So I think there's a lot of people with existing skills who are now getting very excited about using it. I think the other side of things as well is that the part that you don't hear about so much is existing web developers who are currently comfortable with JavaScript or TypeScript. I have a feeling that a lot of those will start looking at the performance benefits of WebAssembly and some of the other benefits, and they'll want to be part of it as well. So I think the JavaScript community will also want to compile to WebAssembly. I think a lot of people will want to target it.
Yeah, that actually was going to be my question, and tying back to kind of the design decisions that you were talking about at the very beginning. It's like the reason for WebAssembly was this performance, this being able to do more things in the browser. But what you described with Rust and C# at least are server-side developers who don't want to write JavaScript. So it seems like two different purposes.
Yeah, and I try not to draw hard lines between languages quite like that. I know that JavaScript isn't terribly popular with some developers. I don't see it so much as bringing server-side developers to the web. I just think of it as removing the monopoly that JavaScript has. So the web is the most ubiquitous platform at the moment, and it's quite bad that we've only got one language that has first-class support. And that's the thing that I want to focus on rather than individual language preferences. They've all got their pros and cons. It's about breaking down the monopoly.
Okay, put on your visionary hat. It's 5 years from now. What does it look like? Have we dumped the browser for conversational interfaces, or perhaps maybe have everything surfaced by chatbots? Assuming we do still have the browser as this ubiquitous platform, what does the future hold for app development using it?
Yeah, I think we'll still be using the browser because it's a fantastic distribution mechanism. 10 years ago, people had desktop applications for their email, whereas so few people open up a desktop application for their email these days because it's so easy to get on your browser, doesn't matter which computer you're at. So that's just one example. The web and browsers are just a fantastic distribution mechanism. And to be honest, I don't see that going away. But I do see JavaScript losing its monopoly. And I do see people starting to write significant applications using a wide variety of languages on the web. But I think there's a chance that WebAssembly may have an impact far beyond the web itself. So if you look at WebAssembly, it's a secure, it's a safe, it's a fast runtime that you can target with a wide range of languages. That's pretty useful in its own right. So for example, if we had a mobile device that supported WebAssembly, you'd have a vast number of developers who would be able to write applications and target that. And we also know on the desktop as well, the number of desktop applications people write and install is diminishing over time. Windows Store, for example, is going to start listing progressive web apps. So Windows Store itself is moving more towards a web distribution model. Add WebAssembly into the mix, and you can start distributing applications that do real heavy lifting, things like CAD applications, things like Photoshop or whatever. It means that the certain class of application that we still struggle to deliver on the web will actually be possible. So I see it making an impact definitely on the web. but almost certainly on mobile and desktop as well.
What place will JavaScript still hold with web? Take, for example, React, or maybe even techniques that are used with progressive web apps. Is WebAssembly complementary to these technologies, or will we see front-end frameworks and techniques developed using WebAssembly to replace the need for them?
So regarding removing the need for JavaScript completely, I see that as highly unlikely because WebAssembly is an efficient runtime, but it doesn't have, for example, things like direct access to the DOM API, and I doubt it ever will. WebAssembly, whilst it's got the name web in it, they have been quite careful to ensure that it will work equally well within other execution environments. So it has web in the name, but if you look at the documentation and the concepts, there's very little web about it. It steered the design. So I do think in future, the shape of a web application in the future might be 70, 80% WebAssembly, 30% JavaScript, with the JavaScript being the glue, JavaScript being the I/O layer, marshalling access to the DOM, marshalling access to CSS and so on, through what WebAssembly calls its host bindings. Whereas in a native mobile application, again, you might have that 70% WebAssembly and then 30% another kind of host binding layer, marshalling interaction with the native environment.
Well, if you want to learn more about WebAssembly, Colin's talk at QCon London will be released on InfoQ.com the first part of June. In addition, later in that same month, as I mentioned, QCon New York will be held in Manhattan. In addition, be sure to check out Colin's white paper, The Web Assembles, at skylogic.com. One last thing. If you're listening to this podcast on iTunes or on SoundCloud, be sure to check out the actual page on InfoQ.com. The page on InfoQ.com has an index show notes that jumps to each of the individual sections of the podcast so that you can quickly go back and revisit things that you heard in the podcast. Colin, thank you again for joining us on the InfoQ podcast.
Cool, no problem.